Okay, and now for this fourth one, we have that carries believes that on a memory retention test, the mean score of bilingual people, UB, bilingual, B for bilingual, will be higher than the mean score of monolingual people, UM, for monolingual. Okay, so Carries gave a memory retention test to a random sample of students in her class. The results are shown in two tables. So as we can see for memory retention, the first bilingual person scored 100. The second bilingual person scored 94%. The last one scored 98%. For the monolinguals, we see that the first monolingual scored 97, the second one 92%, the third one 88%. Okay, that's the information we have at hand. That is the context. Carries then performs a one-tailed t-test. Okay, that's a lot of information. At a 5% level of significance. Damn, that's even more information. It is assumed that the scores are normally distributed. What the hell is that? And the samples have equal variances. What the heck is variance? All right, so some of you probably have a couple questions of what the heck is going on. So let me give it to you straight. This person carries, okay, is seeing who has better memory, bilingual people or monolingual people, okay? And so one of the ways that you can like mathematically prove that, okay, is seeing if the means of each of these two are different. Let's remember that the means is the average, okay? A mean is also like an average, yeah? Oops. So if on average, let's say the average of bilingual, I'm making this up, okay? The average of bilingual is 99, and the average of monolingual is, I don't know, 70, then there's, it seems to be, right, that bilingual people do like way better in memory retention than monolingual people, okay? That's what you would think looking at the means. But to further prove that, there's this thing called statistical significance. Okay, so basically what you're trying to do very intuitively is that you make this sort of test that compares the means. A t-test is for means, by the way. Okay, whenever you see t-test, a t-test is for comparing means. And so you compare the means at a 5% level of significance, which is basically like how much you're asking of the test. So the lower level of significance, the more como the more exigente, the more you're asking of the test. Okay? So basically, it's a sort of test. It runs like a couple, regressions or whatever. I don't want to get into it. I don't know it 100% well, I'll be honest. But the intuition is that you run a t-test, it does like a bunch of samples, and it sees if it's significant or not. It sees if this difference right here is like legit or not. See, because it could have been chance. It could have been chance that, oh, of the people you picked, there's a difference, but it's not always going to be that way. Whatever. Okay, so the level of significance helps you figure out if the difference you have is significant or if it's just by random chance that you have that difference. So, it is assumed that the scores are normally distributed. When you have data and statistics, it can have a lot of different distributions. Okay, and that distribution is a little bit of how your data is like spread out, how it looks like, stuff like that. When it's normally distributed, we have our classic sort of bell curve, okay, where you have your mean in the middle and you have like standard deviations one over, right? Standard deviations one back, and a bunch of stuff, okay? So this is one way your uh, distribution can look like. You also have other distributions that might be like a little skewed. Maybe other ones are skewed over on the other side. Whatever. Okay, so normally distributed, it's like your classic case, your friendliest case. And now they tell us that samples have equal variances. Now, I'm sure some of you don't have the intuition of what a variance is, okay? Variance, I want you to have in mind that variance is basically a little bit like spread of data. See? Standard deviation is also devi, devi, deviation. How the hell do you even write that? Standard deviation is also going to be spread of data. Okay, there's a slight difference between the two. One of these is squared, the other one's not. Okay, and that has to do with handling negative values. Okay, but for our level, for the IB, AISL, just stick with the intuition that variance and standard deviation is spread. And so here when they tell you that they have equal variances, all they're telling you is that their spread is the same. Okay? And because their spread is the same, and this is the sort of thing you memorize, because their spread is the same, because they have equal variances, you pretty much are you're gonna say that it's pooled. Okay? When we use our calculator and in the data section, in the t-test section, if it's pooled, you're going to say yes. That has to do with variances, okay? If the variances are different, they're not going to be pooled together. But that'll come into play a little bit later. So that's the context of what's going on, see? And so here for part A, we have the null and alternative hypothesis of the scenario. Now we need to understand that this depends on how you define it. Okay, a lot of times the null hypothesis and the alternative hypothesis depends on how you put it. Actually, in the answer key, it says like you gotta be consistent. You gotta evaluate consistently with how they or the student define their own hypothesis. But take it easy. Let's take a step back. What's the intuition? The null hypothesis is what they call the H0. Okay, the alternative hypothesis is what they call the H1. And the intuition that I want you to have for this, or that I suggest, okay, is that for null hypothesis is basically that nothing changes. For the alternative hypothesis is that there is a change. There's a change, there's a difference. Nothing changes or no difference, okay? Basically, I want you to associate null hypothesis to no, and alternative hypothesis to something is different, okay? So, in this context, Caris believes that, blah, 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 the mean score of bilingual people will be higher than the mean score of monolingual people. What's the keyword here? Higher, okay? So the null hypothesis in this context, we would say, for H0, we're going to state that the mean score of bilingual people is the same as the mean score of monolingual people, okay? So that's how you would define H0. If you want to put it in math terms, your H0 would be that the mean of bilingual, ¿cierto? So UB, which is this UB here, equals UM, which is this UM here. This U is for mean, okay? Mean equals this U. You're also gonna see that mean is X with a little bar on top, okay? But in this case, we're applying that mean is U. All right, fuck it. So that is for H0. See, so if H0 is that nothing changes, no difference, so that means that we have the same score. For alternative, you can guess what's gonna be. It's gonna be literally like pretty much the same. Just that instead of H0, we have H1. And instead of same, we have that the mean score of bilingual people is higher than the mean score of monolingual people. So what's the key difference here? Here we have higher. Okay? That's all there is to it. See, H0, no difference, nothing changes. H1, there is a change, there is a difference. See? So for H1, we're going to go ahead and say that in line with that Caris believes that the score of bilingual people will be higher. So that means that UB, the bilingual people, is going to be higher than those of monolingual people. So that is for part A. For part B, we need to calculate the p-value for this test. Now, there are a lot of different tests we can do, but this exercise is pointing us towards one. They literally tell us in the exercise, they literally tell us that we're making a t-test. One-tailed t-test. 5% level significance. That's all we need. See? Well, and these tables here. So, I pull up my calculator, and I know I have to do a test. I know statistics. I'm not sure where, okay? But I've gotten familiar with my calculator. I've practiced a lot, and I know some of the tools I have. So, I know I gotta go to stat because it's statistics. And from here, I have 3 tabs. I have edit, calculate, and test. So I scroll around for a little bit, and I notice that, of course, the last one has tests, and I need to conduct a t-test. So here, a lot of people say, okay, The first one is Z test. The second one is T test. Oh, fuck it, T test. See? And then they press the second one. Why is this a small mistake? Think about it. Why is that a small mistake? It's a small mistake because how many groups do I have? Ah, I've got group 1, which is bilingual, and I have group 2, which is monolingual, okay? So that is why, if I go back to the same menu, I have to go down to 2 sample t-test, okay? I have 2 samples, I have 2 groups. The first group is bilingual, the second group is monolingual. So I press the 2 sample t-test. I see what it asks for. See? On the one side, I can input data or I can input stats. All right. If you input stats, you're doing it all by hand. I don't think you ever really use this. So like, forget about it. See? Basically, you enter the mean yourself. You enter the the variance yourself, the standard deviation yourself, the n yourself. You could do it that way, but you take a million more years, and I don't think you're ever gonna have to do it. So just go ahead and go to data, see what it asks for. All it asks for is list 1, list 2, frequency list 1, frequency list L2. These last two things, I'll go over it in a second, see? But for like data-wise, I just need to fill in my lists. So how can I reach list on my calculator? Well, I go to stat because it's a stat problem, and I go to edit because I gotta edit some lists. Boom, there are my lists. Here I have L1, here I have L2. So go ahead and delete all of these. So you can go one by one if you like to do that. So you delete, delete, delete. Or if you want to do it a little quicker, you can go up top to where it says L2, clear enter, boom, clears it all for you right away. So that's just a quick math trick, quick calculator trick. So group 1 is going to be L1, group 2 is going to be L2. Bilingual L1, monolingual L2. Cool. So I literally put in the list that I have there. So it's 194. So this 100, this 94, this 100, this 90, this 100, this 90. And now you guys know what's going on. See, so 100, 94, 98, 98, 98, 98. So that is all the rest of these. Okay. For monolingual, go ahead and plug in 97, 92. So that's these two here. Then we have 88, 98, 88, 94. So that's these next four. Then the last 200 and 100. 100 and 100. Compound, compound. Some of you might be thinking, yo, my data is not aligned. Like, there's more data on L1 than L2. And I would say, yeah, you're right. That can happen. It's okay. Not a big deal. See? Stat, test, 2 sample t-test. I already put on my data. So here, list 1, list 2, I am good to go. Frequency has to do with if this were to have a frequency list, okay? And just to clear this up, because I know some of you are probably like a little bit confused on what that means. For example, if I were to express this first one in a frequency list, I would have, well, I have bilingual, ¿cierto? So bilingual people. I would have score, and here I would have frequency, okay? And so the way that works is that, let's say for score 100, how many people that are bilingual scored 100? So I have 1, 2. How many people that scored 98 are bilingual? 1, 2, 3, 4. How many people? Oh shit, I missed 100, sorry. Frequency 3, I missed this one here. What about 94? For 94, we have 1 and 2. And for 90, we have 1, okay? So if you were to do it with a frequency list, okay, it would be a little bit like this, see? And your frequency over here would probably have to be one of the L1s. So you would say like all of this is L1, all of this is L2. It would be a little bit different, okay? Usually you're not gonna face that, but I think it's good to know what's going on, what's happening, etc. See? So all my data is now aligned, right? For this last part, it's a little bit like it's your alternative hypothesis. Okay, this last part here is literally your alternative hypothesis. So my alternative hypothesis was that UB, right? UB is greater than UM. Now, I have to be consistent. See, which one of these is L1 and which one of these is L2? Careful. Which one is L1, which one is L2? Well, because I wrote it down on my paper and I was consistent and I was careful, group 1 is L1, group 1 is bilingual. So basically, this here for my alternative is the same as L1 being bigger than L2. Well, and technically, given the context, is that the mean of the first one is bigger than the mean of the second one. And so, keeping that in mind, I would have to press this third one here. See? If I press the first one, I would be saying this, which is not the case. If I press the second one, I would be saying this, which is not the case either. If I press the third one, it's literally what I want. It's this, which comes from this. Okay? And then they ask us if it's pooled, and I'm just gonna say right away, guys, you pretty much always put that it's pooled. Yeah, I don't think I've seen in a while an exercise where you put that is not pooled. Put it pooled if the samples have equal variances, which is pretty much always. So just leave it as yes. You calculate, you end up with a bunch of shit. See? So let's go ahead and try to identify what's happening here. So the I'm just gonna say right away, the t-value, okay, so see how I have a t equals of 1.22 and I have a p-value of 0, 1, 19, 0, 119, sorry, 119. So I don't want to get too into it because I know statistics can be really fucking weird. But point is, this t-value and this p-value can help you conclude the test, okay? And depending on what you compare it to, you either use t-value or you use p-value, okay? In this case, because we have a level of significance, we will be using our p-value, okay? That's literally it. So, that's the information it gives you. DF is this thing called degrees of freedom, okay? It doesn't really matter. Forget about it. You barely use this, okay? X1 and X2 with the bar is the means. The S's, I'm pretty sure are variances, see? And then we have the variance that's pooled, okay? I think so. I'm pretty sure. Yeah. See, don't worry about it. N1 and N2 is the amount of data you have, see? Whatever. A bunch of shit shows up in your calculator. The only thing you really care about are the first two, see? The t-value and the p-value. And so for part B, the value of P for this test is literally right there. So part B is this. Kapow. Not that bad, eh? Not that bad. And now for part C, we need to state the conclusion of the test in the context of the question. All right, so how do you interpret this? And again, this is very much like sort of like a rule of thumb, okay? If the p-value is bigger than your level of significance, when I say level of significance, it's this guy here, okay, 5%. If the p-value is greater than the level of significance, notice the language. You fail to reject HO. You fail to reject HO. And in very, very fancy math language, you would say that there is, because p-value is greater than level of significance, there is insufficient evidence to suggest that bilingual people have better memory retention than monolingual people. Okay? That is the very fancy math way to put it. This is also literally like from the answer key, okay? But yeah, that's what you end up with. See? And so notice how this P right now is in decimal. See? So I can either say that 0.119 is greater than this 5%. See how to express 5% in decimal, 0.05. And so that is what tells me that I failed to reject HO. If you want to express it in percents, you would have 11.9% being greater than 5%. Okay? Either of these works, both are under the answer key, stick to what floats your boat. See? But yeah, that is pretty much it. So for part C, that is what happens. See? This is one way to define it. You can define it however you want. Um, but the key, very key information is that you put that you failed to reject HO because of this guy here. See? Again, this is sort of thing you just kind of have to memorize. You can end up learning it, but for now, stick to it intuitively, okay? If p-value is greater than level significance, fail to reject. And always define it the same way. Because technically, you could also say here that you accept HO, see? And some people like to think about it in terms of accept. Other people like to think it in terms of failing. But then this is also double negative because it's fail to reject. So it's a little bit confusing, guys. All I'm saying is stick to whatever helps you understand it better, okay? But anyways, that is parts A, B, and C, and that is for number 4.